Welcome back. So next one, we are trying to find the sum of the n numbers. Example, if the input is 5, then 1 plus 2 plus 3 plus 4 plus 5. But if it is 6, the input 1 plus 2 plus 3 plus 4 plus 5 plus 6. Likewise, we will do. How many inputs are here? Just think. We have only one input. So whatever the method name, you are passing one integer, right? And then you have to sum 1 till x. This is going to the logic. Let's discuss inside the code how we'll do that. So first, think of the method signature. It will be public and it will return a number again. So return will be integer. So whatever you write before this method word is the integer. You might be thinking, I'm not telling you method and all that for now. I just want you to practice first and later we will come back to discuss each of these keywords and their positioning. I'll call it arithmetic sum. Some other convincing one. Sum till num. All right. It is going to take one number and definitely is going to return me the sum of the number. Well, do not worry about this quickly red color wavy lines, because that is helping you to tell, hang on, you are looking for returning something. There is nothing here you have returned. In the beginning, to be on the safer side, to understand, you can just say return 1. Gone. But now you need to think of. So let's say the number is 1. As you said, if the number is num, you have to sum till 1 plus 2 plus 3 plus n. To understand, you have to add 1 plus 2 plus 3 plus 4 plus 5 until it is the number has reached. Which means if the number is 4, it will stop at 4. If you know the for loop, I'm just assuming that theoretically you all know what is for loop. The for loop is running on the given condition. To do the for loop here, you just need to write the for and hit the tab twice. And to break the monolithic assumptions of I, j, and k, I'll check it run instead of I. So the trick here is the moment you write for and tab, it will go and create the for loop with initialization of a variable called I, and that is on the highlighted mode of I. You just write instead of the n. If I write it here run and press done, press tab, everywhere it is I, it would become run. Right? And then you have to think of this run has to run till what? Now this for loop is going to say add 1, then add 1 an outcome to 2. Now if you are not familiar with this logical concept, I'll go here and explain you. So let's assume you have a box and this box has many numbers. You have another box which stores the sum of any numbers. All right, so I'll pick it 1, just dump it here. And then next number when you take, you say, hang on, take whatever is the outcome over here, the full sum, bring it back to me, and then add the next number. Now this animation was not so clear, so I'll borrow it. And this is the sum. And these are the numbers. Assume the value of the sum in the beginning is 0. And then I'll say, give me the next number. So there's a gentleman who says, give me the next number and give me the outcome, current value of the sum. So 1 and the current value of sum 0. And he will do the sum of only 2 numbers. The value in this is current value in this box, which is current in the sequence value in this box is 1. He takes it. And it always sums with the current value of the total sum, 1 plus 0. And whatever is the outcome, he feeds it back to sum only. That's it. Now again, after this activity is done, I'll give the numbering 1, step 2, step 3. That's it. So step 1, take the number, take the sum value, sum it up, and give it back to sum. So what will happen at the end of this value is, if it was 1, it will be omitted and it will be summation value 1. Now after that, it will again take the next number from this sequence, which is 2. Take this number now, and the current sum value, next step, is 1, you can see. So 2 plus 1 is now 3. So this time it will replace from 1 to 3. Now the next stage is, again take the next number, which is 3, and then take this number, which is 6. After that, take the next full number from this sequence, is 4, and take the total value of the sum, which is 6, 10. Again, you take the next number, which is 5, and the total sum is 10, which becomes 15. And then you have to write a logic that, hang on, I've reached to the last one. I don't need to add further. Now, I'll probably make one more way of doing it, which many people do. All right. So now I have 5 numbers. I wanted to send it to back. I'll try to take this as a front. Still not happening. Anyway, so let's say this is 1, 2, 3, 4, 5, and they're in the sequence. I'll start picking from this side, 1 and then 2, then 3 and then 4 and then 5. And this is the box which has sum. And naturally, first you take the first number, take the current value of the sum, which I said begin with 0. We'll take 1 and 0, and whatever is the outcome, you give it back to sum. So you give the current value, you add it with the next number from this sequence and give it back. Step 1, step 2, step 3. After this is done, you go for the next number, not the same one. Or you can say after the stage 3, step 3, you have to move to the next. So I move from 1 to 2 and take that number. And then take the current value of the sum. What is the current value of sum? Is it 0 or 1? 1 plus 0 is 1. I think it is 1. We'll cut it. So current value of the sum is 1. It has happened earlier itself, not now, when we had summed it. So 1 is the current value. So now you'll be giving that 1 over here. And 2 plus 1 this time becomes 3. And now 1 will be replaced by 3. Now next stage after this is again move, which will move from 2 to 3, and then pick the number. So which will be 3 plus the current value of the sum, which is 3. And that goes back over here, which is 6. So 3 will be replaced with 6. And then after that, move from 3 to 4 and pick that number. So 4 plus the natural sum till now is 6. which is 10. So this time it will be 10, and we will be replacing 6 with 10. And after that, next you have to move from 4 to 5. You'll be taking 5, and then the sum value 15 goes over here. And then you try to move, there's nothing. You will say, hang on, there's nothing. This is going to be the final value. Give it back to whoever has called. All right, so same way we have to find the way. So this movement is done by the for loop, moving from 1 to 2, and all that things we'll be doing it inside the for loop. So I have to move from 1 until 5. All right, I have to move from 1 until 5. So I should not be moving from 0. I should move from 1 until 5, which means less than 6. All right, or less than equal to the number. So now I hard coded 5, let's say. And then we will say this step only we will write inside. All right. So we'll say the new value of the sum is equal to the old value of the sum plus the value inside the run, because run is nothing but moving and taking the next numbers. All right. That's it. But now it says I have not defined what is sum. Naturally, sum is a number which you want to use inside. So you have to define it. That is again an integer and sum. What is the beginning value of the sum, if you remember? We said take it 0. Now you think what will happen the first time? 0 plus 1 becomes 1. And the next time, 1 plus 2 becomes 3. And then 3 plus 3 is 6. Likewise. And then whatever is the outcome, that you return at the end. I give you 10 seconds here. And anyway, when we will run it line by line, you'll understand that. Done. Let's keep a breakpoint. As we know, the quickest way of doing the breakpoint is take your mouse into this ribbon area. There's some other names also which is not coming accidentally right now into my mind. You just take it yourself into this gray vertical ribbon area, and you see a circle darker color. That's the breakpoint, which means the code will run till then and then stop for your action. I'll stop it here, and then we will run, because I want all this code to run by itself, and only when the square till number is called, we have to. Have you really called square till number? We'll get to know that. Now, while it is doing, I just want to tell you that in your code, you are actually not calling sum till number. You have provision for calling sum till number, but you are not calling. Until unless you don't call, it's not going to get invoked. So I can call sum till number. And to call sum till number, I have to tell where that sum till number is. The sum till number is sits inside this class. And instead of calling this class, I have a copy of this class which call an object, and that we have done in this line. The copy of CSS Math Logic has something called obj. So instead of calling this class, I can simply call as an alias, you can say, which is not an alias, we'll discuss it later, dot sum till number. And let's say I pass 5. Okay. There are some logical mistakes purposefully done. We'll see that later. And whatever the outcome is stored in a result. And then our famous line, pencil right line, call it for result. Now, while I'm typing this, a normal question comes to everyone's mind. I'm not able to understand this. Well, naturally, this could be reason you are doing it the very first time in your life, or maybe Very first time, honestly, you are doing it. Or maybe you have done it 4 or 5 times, but this is the first time you're trying it. I'll tell you, you try the same question maybe 10 times. You go through these 3 videos, maybe 20 times. You will understand what is we are trying to do. Your learning pattern will get into almost the subconscious mind, and probably it will let you understand the way of working. Once that is done, the discussion and everything becomes easy. Focus on this question as much as possible for 5 times, and you will be in the sync. All right, so this time if I run it, it will definitely go and stop at the breakpoint. It has. I can hide this probably. Yeah. And then to run it after that line by line, if you don't run line by line, it will simply jump from here till here, executed everything, do this work, and then just display the data. We don't want to do that. We want to see after this line, let it come here and see what happens. All right. Now I will click this, that is called go line by line, step info. All right. Now, another beautiful thing with Visual Studio is if you take your cursor onto any of the variables, its current value can be seen. Now, the very first time it takes time, what you do is you click it over anywhere and then click it back over here. All right. And then you take over the cursor over there. Don't click on that. You just hover over there and you slowly go down. Don't go like this. It goes away. So if you click somewhere else, like here, it goes. So you have to get inside of it and then you pin it. Once I have pinned it, the value is being displayed and you can continue and see what happens. Likewise, let us pin the sum. Now here people have a problem. You can take your mouse little at the corner and drag it like this. Likewise, I want it for run. Since the run has not been created yet, you will not be able to pin it. So once it is created, you will be able to pin it. Let's check the run value. As I said, slowly like this you do. Done. Now let us run it down and see what happens. The run value has become 1. It is checking, is run less than 5? Yes, it is. It will go inside. The for loop, how it works, I'll probably quickly revise it for you all, but assume you know that. So the moment it is less than 5, it goes inside. I should probably explain that part first, that how that for loop actually works in the life. Many a time we don't know. It's a good time to explain you that piece. So the for loop, the first part is initialization of some integers, which is optional. You can many a time omit it and don't write anything. What I mean to say is, well, somebody wants, he could have done like this. Just delete it. Though the nature will change, but if at all somebody wants, he can create a for loop without initialization part. And after that, the run is 1. The next step is it goes and checks this condition. Is the value of run less than 5 means true or false? 1 is less than 5. Yes, it is true. Only then it goes to here. Then it executes all the line inside there and it reaches here. Once it reaches here, it goes to here. Now, if you know a little bit of this piece, it is just going to increase the value of run. The current value of run was 1. It will increase it to 2. Now think after this stage where it will go. So first step was 1 this, second stage was 2 here, third here, all that stages. Then maybe it's a, let's say 10th stage and then goes to here, right? I can say it's a true understanding third stage, then I can say whatever. After this, it goes back to nowhere else, but again check. So this check and this will be repeating these 2 stages. So to understand, you can make a graph in your mind. Here, then here, then here, and then here, and that goes here. That was it is. I remember is like this. You can think of. Starts from here, gets inside, then do this all. Keep doing it. Do your work, increase, check. Do your work, increase, check. Start, get inside, all the work, increase, check, get inside, do the work, gets back, increase, check, check, do, increase, check, do, increase, check, do. Like that it does. We'll be seeing it here anyway. So now the sum value is 1 because it started with 0 and the last value plus the run value. Next, it has increased the run value now, plus 1. So sum value has become, run value has become 2. Is 2 less than 5? Yes, it is less than 5. Gets inside. Now it is saying the old value of the sum it will take, which is 1, plus the run value, which is 2, and give it to the sum itself. So this is a little interesting, which is not like a common arithmetic. Sum equal to sum plus run. It is not a formula or something. It is saying take the values from the left, assign it to right. The equal to sign here is not actually equal to sign. It's an arrow kind of sign, assignment sign. If you really want to compare two things, you have to use double equal to sign. All right. Sum is 3. Run will be increased to 3. Still check 3 is less than 5. Yes, gets inside. And then the value of the sum is 3. Value of the run is 3. You can probably pick these things here. It helps. Yeah. So 3 plus 3, it should become 6. And the new value of the sum is 6. It goes back here, increase the run value from 3 to 4. Is 4 less than 5? Yes. Gets inside. Yeah, because I did small change, it's trying to update the code because there is a line change. Will not take much time. All right. 10. Now run will become 5. Is 5 less than or equal to 5? True. Gets inside. And then 5. Earlier value of the sum was 10. Now adding the value of run 5 becomes 15. Run becomes 6. Now, is 6 less than equal to 5? It's 6 less than equal to 5. 6 less than or equal to 5 by any chance? By ever? 5 is smaller than 6 actually. 6 is not less than 5. Neither it is equal to. So it's a wrong, which is false. The moment this condition becomes false, it won't get inside. We'll simply go to jump till end, outside the end, directly gets to the next line. You can check it. See, it has come directly to the return. And whatever the value of the sum, which is 15, will be given back to whoever has called. Who has called sum till now? This gentleman here. So this will be given to the result. See? If you check the value of the run, actually the earlier value of the run coming from this execution. Now it will change to 15, which is a square ka code. And that becomes 15, and that you'll be printing. Done. Thank you. I think I need to go a little more in detail if it is required, or I can run one more time probably. Let's check it. Run it. While I'm doing it, think, what's the mistake? What's the mistake? To understand the mistake, anyway, the internal part is right. You can anyway run it and check. The mistake lies in, what if instead of 5, I pass 6? You calculate yourself should give 21. Is it giving 21? I have passed 6. It should give 21. 1 plus 2 plus 3 plus 4 plus 5 is 6. You can add it. 1 till 5 is 15 and plus 6 is 21. Actually, it is still giving you 15. Where is the mistake? The mistake lies, you are passing 6, but you are actually not using it. If you see the value of the num, it is 6, but nowhere in the code you are using the value of the sum. You have to think what change I need to do. And that is the way of actually writing the code. First, you write hard-coded fixed value, and then see where to do the change so that it works for other options as well. So I want to show you the value of the num is definitely 6. Here you can see it, but are we using it? I doubt. How many times this should run? It should run till 6, right? Not 5. That's the interesting part, right? It should run till 6, not till 5. So let's go and hard code 6. No need of hard coding 6. Whatever is coming, pass that over here, which means instead of the value, you give the name of the variable. That is what is the beauty of a variable instead of a data. You give the variable name that turns out to be useful. Now, if you run it, you would realize that it is working for any number. So let's run it for 10. You quickly do the sum till 10 and you can find out. It should be 55, I guess. Should be running 10 times. I'll go a little quicker and somewhere we will check it. It has run till 6th one, already 7, 8, the 9th one, and now it is the 10th one. The value of the sum by the 10 is 55. And since it is already done 10 times, increase to 11 and exit, and that's the value 55 will be given back. That goes here and display 55. I'll suggest to do some kind of animations yourself also to understand, because the logical questions, how hard we do on the coding, you need to do some kind of your mind mapping, right? That's it for now in this video.